till now, we have discussed some basic data structures, and in yesterday's session, we have also discussed the loops, the for loop and the if-else conditional statement and the while loop we have discussed. Today we will discuss functions. Like any programming language, Python also has a lot of predefined functions. So these predefined functions are critical because they will help us to do things or automate repetitive tasks. So when you're doing any repetitive tasks, it's better to write them into a function and store it so that you can easily run them as and when required. So that is the concept of functions which we are going to discuss today. So till yesterday we were doing these functions, loops and condition statements. So today we will discuss Python functions. Functions are defined in Python using the keyword def, and the function will have multiple number of arguments, and these are executed when the function is called. So functions are predefined, defined using the keyword called def. The keyword is the def. So we have to use the keyword def, and then we have to give the parameters of the function. So then we have to give the arguments in the function, and then to execute the function, we have to call the function. So if we are looking at, let us see what exactly is function. So this is the context of a function, how to look at a Python function. So function is a block of code defined with a name. Every function should have a name. So function is a block of code defined with a name. Here, if you see, the function starts with the keyword def, and the function name which you have to give is add. Here we have given a function name called add. You can give any function name, add, and then next to the function name you have to define the parameters. You have to define the parameters or the data which needs to be passed into the function for execution. Then you have the function body and the return keyword. The return keyword will give you the output. Return value is given by the return keyword. Def is the keyword and return is another keyword which you need to use in these functions. So these functions are used in such a way that repetitively you can use those functions multiple times without writing code every time. So that is the basic logic behind the usage of functions. Whenever you are doing a task multiple times, it is always better to automate it by writing it into a function. So the function is a block of code defined with a name. That word keyword is def. You have to give a function name. Then you have to pass on the parameters next to the function name in parentheses. Then you have to give the core argument. The core argument here is addition is equal to num1 plus num2. The core argument here is addition is equal to num1 plus num2. And return the output as addition. Now to use this function, you have to call the function using the keyword, which is add, for using a function name, sorry. Result is equal to add 2 comma 4 function call you get, and then you print the result, you will get the output. So this is the basic structure of a function in Python. A block of code that runs when it is called. The block of code when it runs when it is called. So function is a block of code which will run when it is called. So that if you look at the key terms here, first you need to use the def keyword, then the function name, then the core argument addition is equal to num1 plus num2, then the return keyword. Now, and you have to call the function. So how this works, let us execute the same code as an example. What we see here in the example here, that only we will see, and then we will study it. One second, my collab is hanging. Just a second. Yeah. And just running all the mark cells just to make sure. Okay, so let us execute the def function which we have here. We will write. So def is the keyword we should start with. Then we will name the function as addition. Let us say I'm using addition. This addition is the function name. Num1 comma num2. These are the parameters, followed by semicolon. Then addition is equal to num1 plus num2. This is the argument. And if you want, you can then the return statement, followed by the return statement. Return addition. So this is a simple function which we have written. So def addition is the name we are giving to the function. So if you are looking at def and return are the keywords that must be used. Then the argument is, sorry, parameters. Parameters are num1 and num2, and the argument which will be executed is now addition is equal to num1 plus num2. Function call is addition parenthesis. Addition followed by parenthesis. This is the thing. So addition in bracket 2 comma 3. Oh, we got an error. What is it? Addition no doc string. Okay. Why we didn't get? Okay. Result is equal to addition print result. Oh, why function call is not working? Addition is equal to df addition, add addition num1 num2 colon. Addition is equal to num1 to return addition. Range. Just change the name. Maybe keyword thing is getting stuck. I think I gave the same name, so that is the problem. I forgot I. Okay. Add. Yes. So you got the result as out 5. df add num1 num2 addition is equal to num1 plus num2 return is equal to addition, and then you got the result as 2 comma 3 5. So this is a simplistic form of how the def functions are written in Python. Followed by the function name. I forgot. Add is the function name. So in functions, you can give multiple parameters, and in function indentation is also very important. So code indentation is also very important. The way it is executed, I'll show you an example how it is executed. The code indentation is also critical here. All right, can I move forward? Yeah, can I move forward, participants?
Yes, yes.
Okay, let us do one more example. Area of a rectangle. Area of a rectangle. The formula is length into breadth. So let us calculate a simple function def, the keyword, area underscore rectangle in bracket. You have to give two parameters, length comma breadth column. Area is equal to length into breadth, and the return keyword return area. So here we what to call we can we have defined the function. Now we are calling the function. Let us say length is equal to 10, breadth is equal to 6, then area of rectangle. So we can add the print function here for the output, like print area of rectangle colon area rectangle length comma breadth. You can see the area of rectangle is 60. So we are executing the function in the print statement. We are executing the function, or we are calling the function in the print statement here. So def area underscore rectangle length comma breadth colon area is equal to length into breadth return area. We assign the parameters and then print area of rectangle area length comma breadth. So this is how we define the functions in Python. They are predefined functions. All right, all of you got this? Okay. Now this is how a simple function will look like, but you can also write complex functions like, let us say, if you are looking at permutations and combinations, permutations and combinations. So if you look at the formula, permutations and combinations formula, so the permutations and combination formula involves multiple calculations. You have the formulas are this: n factorial. First, you have to calculate the factorial. Then for combination, n factorial by n minus r factorial multiplied by r factorial. And for permutation, n factorial by n minus r factorial. So permutation and combination involves multiple function calculations. So let us start. Let us write a small function that will save this formulas, permutations and combinations. So let us say import operator as OP. This is a library within base Python. Then we'll write first the factorial of a num colon if num double equals to 1 colon return num, else, or instead of else we will say return only, return num into factorial num minus 1. So factorial of 3, 6. Factorial of 1, so factorial of 1 is 1. Factorial of 5. So this is the code for factorial. So we are getting the correct answer. Next, we need to write the second function for, so let us say this is for factorial. Now first we will write permutation. df permutation parameters are n comma r colon return int factorial of n divided by factorial of n minus r. So factorial of n divided by factorial of n minus r. So this is the formula for permutation. As you can see here, the permutation formula is n factorial divided by n minus r factorial. So this is the n factorial number. We are getting the correct output. Permutation n factorial divided by n minus r factorial. So this factorial will refer to this factorial function which we have created here on the top. So print factorial of 5, print permutation. So we have to give for permutation 2 arguments, 5 comma 2. See, permutation of 5 comma 2 is 20. 2 arguments n and r we have to give. So the permutation is 20. Factorial is 5. Okay. So
Yes.
yes, please. Yeah, my screen is not visible, participants.
Yeah, it's visible, sir.
Yeah, okay. Okay, now we will write the code for the combination. DEF combination, again combination requires two parameters, n comma r colon return int factorial of n divided by factorial of r multiplied by factorial of n minus r. So factorial of n divided by factorial of r multiplied by factorial of n minus r. So we'll run the code, and then to see if it is done properly or not, we can add the additional print command here. Print combination I comma 2 360. So we have, for calling the function, you have to use the name what you are assigning next to the DEF. And you have to give the parameters as many you are specifying in the parentheses. If you are specifying 3 parameters, you have to give 3 parameters. Here we are specifying 2 parameters. For factorial, we specified only 1 parameter. Okay, but permutation and combinations read 2 parameters, n comma r, ncr and npr. So we have to give 2 parameters for those functions. So the Python is having a lot of these predefined functions. Python is having all these predefined functions. So nowadays, requirement for writing the function code is very limited and very niche thing, but most of the Python functions are predefined, so that non-programming guys are also able to use them. So if you are looking at how this thing works, so if you say, uh, let us say, let me show you an example. So pandas data frame mean. You can click on the source. So this pandas is a library like I discussed in the first session, where you have a function called mean. Mean is nothing but the average of numbers you will get. If you click on source, there you see the backend program. See here, def mean. See, this is the Python code for pandas code for the mean function. You can see here. So once you go to the documentation and once you see the function name, you can see here pandas data frame dot mean. Next to it, you will see something called source. If you click on source, you can go to the function code. This is the function code for mean in pandas library. So df mean self axis skip NA bool is equal to true, numeric only bool is equal to false. So you can see here, this is the code which is used for calculating the mean in pandas documentation. So this is the def function. So there's all are predefined functions. So a lot of predefined functions are there. So if you see in the below mean only, you'll see the function for median. This is the predefined function for median. So the requirement for coding is not required there nowadays in Python because most of the functions are predefined. You can just call them as mean and you can directly use it in your data analysis. So the requirement for coding, writing of function is very, very minimal in Python. But sometimes for specific activities and specific works, we have to write the functions. So if you are writing a function, you need to follow this syntax. Got it, guys? Any doubts?
Sir, can you explain this combination syntax once again?
Which one?
Combination.
Combinations.
Yeah, in the combination we are using alternator. Yeah.
This is the factorial by the combination formula is there, no? So the formula is n factorial by n minus r factorial and r factorial. See here, n factorial divided by n minus r factorial into r factorial. That is what I am doing. Int of factorial of n divided by factorial of r into factorial of n minus r. This factorial is referring to this factorial function.
Yeah. Okay.
So here we have used multiple functions in one single function. df we have written factorial, df permutation and df combination.
Okay.
Okay, can I move forward, guys?
Yeah. Yes.
Now you can also use these df functions with the loops. You can also use the df functions with loops. So let us say I am defining a function here, def square of a number y column. What is square of a number? Return y to the power of y, or you can say y start 2 also, or you can say y into y. So square of 4, 16. Now you can use it with the for loop. The function which you have used, you can call it in a loop also for x in range 1 comma 11 colon print square of x. So it will square all the numbers from 1 to 10. It will square all the numbers from 1 to 10. See here, 1, 4, 9, 16. So we are calling the function in a loop here. We are calling the function in a loop. We defined a function and now we are calling that function in a loop. All right. So you can call the function directly in a loop also. Like here, we are squaring the numbers with the range from 1 to 11. Okay. Now these functions are functions with name. The def functions are functions with a name, like def followed by the function name. There are something called anonymous functions or lambda functions in Python. There are some functions called anonymous functions or lambda functions in Python, functions without name. So that is another thing we have. Within Python, we have something called lambda functions. Lambda functions, which are functions without name, or also called as anonymous functions. We call them as anonymous functions. So these lambda functions are very important in Python because they help you to do lot of these things, work without doing lot of syntax and all. So if you are looking at a typical lambda function, it looks like this. Python lambda function, nameless function or function without name. So let me just take the right example. This should be the best one. So the structure of a lambda function is this. Function is equal to lambda. The keyword lambda must be used. Then you have to give the parameters or the multiple arguments x comma y colon the expression x plus y. So it will take two numbers and it will sum those two numbers x plus y. So function is the name we are giving to the this whole thing. Lambda is the keyword which you need to use to define a function. Then the arguments are x comma y colon x plus y. The colon is must be used as an equation symbol here, equality thing, and then the single expression to evaluate the and return the result, that we call it as x plus y. So this is the structure of a lambda function. So lambda functions are functions without name. So the keyword is there. So you have to give the lambda before the keyword, before the argument or the expression. Before the arguments, you have to give the keyword lambda. Okay. So whatever there in the code, let us see. I think it's again going to crash. 1 second. Let me refresh. There is a problem with collab notebook. So if you lose the connection with the cloud server, it will get stuck. Yes, got completely white screen. Now we got it back. So func is equal to lambda x comma y colon x plus y. The example one which I am writing here, func 2 comma 3. See 5. The same add thing in the top, I have written a function for addition, right? If you remember the beginning of the session, to explain you to add two numbers, we have done the same example. DEF add num1, num2, addition is equal to num1, num2, written is addition. So this whole thing, which we have written in say 3 lines, is written in single line using the lambda function, lambda x comma y, x plus y. So see, there is no key, what you call, except the keyword lambda, not much of a syntax. No def, return, name, nothing. So fun is equal to lambda xy, x plus y. So this is anonymous function, functions without name. So if you are to look at a function with name, same thing here on the top, which I have written here, addition, def add, num1, num2, same def function. When you write it using a lambda keyword, this is how it looks like. So no syntax, nothing. So it's a very simplistic thing which you can do. Similarly, let us say square. We have written a function for square, right? Square sqr is equal to lambda x colon x star x. Same thing. SQR of 4. You get 16. So what we write in the top, def square and all, then we executed using a for loop range and all. So you can see here. You can also write it with this also, for loop also. You can simply say square. So anonymous functions, functions without any name. And one important thing you need to understand is the difference between the DEF function and the lambda function. So I'm just pasting the difference between both the things, DEF versus lambda. You can see here the difference between DEF function and a lambda function. So this is the difference between the two. Keyword DEF, keyword lambda, return statement is merged. There is no return statement in lambda. Return value integer, return value is a function object. Computation time is slower, computation time is faster. Simplified and single line. Okay. Now let us use this lambda function with a little bit of expanded things. So start is equal to int input, enter a number, colon and space, end is equal to int. This input will create a input box, enter a number, colon, space, start and end. Now we will look at even numbers. Even underscore num is equal to list filter lambda x colon x modulus 2 double equals to 0, then range of numbers start comma end plus 1. Why we have to give n plus 1? I told you yesterday, outer range will ignore the outer value. If you say range 1 comma 11, then only you will get 1 to 10. Otherwise, if you say range 1 comma 10, it will do till 9 only. So this is the argument for even numbers. X modulus double equals to 0 is even number. So you can give a print command here. Print even numbers are colon, and then you give the even underscore num, the output value. Similarly, odd underscore num is equal to list filter lambda x colon x modulus 2 not equal to 0, comma range start comma end plus 1. Print odd numbers are colon and space, then comma odd underscore num. So this is the lambda function we have used. Identify the even numbers and the odd numbers. So let us say I am giving 20, end number is 35. So what are the even numbers between 20 and 35? 20, 22, 24, 26, 20, and the output is given as list. So within the range of 20 to 35, what are the odd numbers? What are the even numbers? So here, see, we don't need to write the DEF function for even number and odd number. Here we are just using a single line for doing this. So this is the advantage of lambda functions or functions without name. All right, can I move forward? Any doubts, participants? Yeah, we have used in loops also, right? This range is a loop, iterator, na? Range is an iterator. Okay, can I move forward?
Yes, sir.
Now, till now we have used numbers only, but we can also use string as an input. We can also use string as a input also. So let us say words is equal to str input str is string input enter a sentence. So in yesterday's session we were using int input enter a sentence. So we can enter a sentence colon space. So yesterday we worked on some string functions also. So words is equal to string input enter a sentence, where you have to give the string input. It will not take numeric input, or even if you give numeric also, it will convert it into string. So string input words is equal to str input enter a sentence colon space. Then we'll split the sentence into words. Words is equal to list of words dot split. So dot split will break the sentences into words. In the top, in yesterday's session, we have discussed it. If you remember in the string functions yesterday, when I talked about the string functions, basic string functions, which we have done. See here, dot split will break the sentences into words. You can see here, Python is a data science programming language. The sentence is broken into words. You can see there's comma between each of the word. So same thing here. This will break the sentence into a word. Print words. We are printing the output. So if we want to see this function simply, so Python is a data science programming language. See, it broke it into words. Once you input, you press enter. It had broken the sentence into words. Now we will run results is equal to map lambda w colon square bracket w dot lower, that means convert it into lowercase, comma w dot upper, convert it into uppercase, comma len of w. Now what is the length of the w, comma words. See, so we have given multiple function here. So print list results. So Python is a data science programming language. Press enter. Oh, we have made a mistake. Map. So I didn't close. Okay, so I closed the square bracket in the wrong place. Square bracket should close after length. Because what words is the data reference? The square bracket should close after length. Python is a data science programming language. Okay. Or if you want to see the results in a simple manner, for I in results, print I. This will give you results in a proper way. You can remove this. Right, copy paste. See? Now you can see the results one by one. And it is counting, giving you the length of each word character. So this all functions work with both numbers as well as text or string data. So these are the arguments which are executed till here. This is the data reference we are giving the words. Once you're done, please confirm. So this lower, upper, length are all string functions. Yesterday we have done them individually. Now we have used it with lambda and we have done it on a sentence. Okay, so you can also write some complex functions both with def and lambda. So that also can be written. So let us say start is equal to int input enter start number colon space end is equal to int input enter and number colon space num underscore list is equal to list range start comma end plus 1 comma 1. Step is 1. So range start n plus 1 incremental by 1. This 1 is stepwise incremental. That means we have to go one step incremental. So that is what we're going to do. So let us say print num underscore list. So start number 10 and number 20. See 10, 11, 12, 13, 14 till 20. So we are incrementing by one step. Now for this we will write def cube of n, or let us say num colon return num start 3. Return num star 3. So this is a cube function which I have written. Next, we will write a function def square of num colon return num star 2. Now we will store these functions as a list. Func is equal to cube comma square. Now for I in num underscore list colon results is equal to map lambda x colon x square bracket I comma function print list results. Start number 10 and number 20. So we can see here, we got an error. Okay. Results map lambda x colon x square bracket I. Correct only. So why it is being okay. I think we are having some problem in the definition. Oh, where it is being print list results, where is the error coming from? For I in num list, okay, results is equal to map lambda x colon xi comma funcs. Print list results. Why it is saying, let us see, explain the error. Explain the error. So Gemini is thinking. Okay. Okay. Oh, I used wrong bracket. See, it suggested this one. You are using wrong bracket. See, using x round brackets. I was using square brackets. So that is the problem. X round brackets or parenthesis I. 10, 20. See, we got the values. Cube values and square values. So one small mistake here. So I gave square brackets here. This has to be round parenthesis. X colon X parenthesis I. All right, all of you getting this?
Yes, sir.
So this is how you can create your user-defined functions, whereas in Python, we already have a lot of predefined functions. So if you look at NumPy also, a lot of predefined functions are there. So if you click on source, you can see the code. See, DEF mean is a code for mean, arithmetic mean. So there are a lot of predefined functions which are there. So similarly, you can also write your own functions. This is the backend code for the mean in the NumPy library. The earlier one which I showed is the pandas library. This is the NumPy library. The mean we are looking at is the NumPy library. So if you click on the source, you will go to the source code, which is a GitHub source, where you can see all the what you call predefined functions which are there in Python. And user-defined functions you can create based on your requirement using this methodology. So this is the function syntax of Python. So let me run all and then so Python is a um, okay. So any doubts, participants? The functions, DEF functions and the lambda functions. So in the 3 sessions which I have completed till now, we have covered the basics of the programming part. Tomorrow, we will import a data set and do the basics of this statistics part.